Guys, this is Log Lab 3 on log laws. All right, so before we do log laws, we're going to review logs. All right, so this is what we did on Wednesday. This is also part of our previous labs where we just evaluate the log. And remember, a log can be turned into an exponential, and the answer to a log is an exponent. So this is basically just asking us 3 to what power equals 3. All right, so we want you to be fluent with skipping this step and just being able to say, okay, log base 3 of 3 is 1, because 3 to the first power is 3. All right, by the way, I should have mentioned this. This is not in your packet. If you are using the Kami document, you will see it. If you just have your log packet, that blanked back page is a good place where you could write some of these examples if necessary. Okay. You might want to, you not necessarily have to take notes on this page, but maybe when we get to the newer stuff, you want to write some of this stuff down and you have a blank spot at the end of your packet. All right. This next example is a special case, right? Log base 3 of 1. Well, we said if the input is 1, the output for a log is always 0, because to get an answer of 1, you have to raise something to the 0 power. Okay, and you might want to pause and do these on your own just for practice, and then play the video to check. 4 to the second power is 16. Here we have a common log, so this is really log base 10. And since we have a fraction, we know it's negative. And since 10 squared is 100, then this would be a negative 2. And for 36, we're getting smaller. So this is saying 36 to what power is 6? So it has to be smaller than 1. Okay, smaller than 1. It's going to be a fraction. And I know the square root of 36 is 6. So this is going to be to the 1/2 power, because the square root of something, is the same thing as the 1/2 power. Okay. All right, so we're going to get into the log laws now. And since the logs are basically just, we can convert them to exponents, we're going to use the same exponents. So the base stays the same. And just like exponents, when we see multiplication, it can be expanded and turned into adding those exponents. So when you see the input, there's two things being multiplied, we're going to expand it, and each piece, notice, has that same base b, but we're going to add them. Okay. Division turns into subtraction. Okay, just like when you're dividing exponents, you subtract them. And when we have power to a power, okay, when we have something raised to a power, we're going to turn that into multiplication. So, and I just want to reinforce this first before I get into the variables. Let's say we have log base 2 of 8 plus log base 2 of 16. And according to the log laws, that's going to be the same as the log base 2 if I multiply these together. And 8 times 16 is 128. All right, and if I evaluate these, hopefully we know log base 2 of 8 is 3, plus log base 2 of 16 is 4, and 2 to the 7th power is 128, so log base 2 of 128 is 7. And you can see how this works, right? So if I have a product, this is the same as 8 times 16. You can expand it, okay, break apart this product and add the two numbers separately. So basically that's what we're doing with the log laws. We're expanding here. So log base 3 of by. Now by is really b times y. So the log law says I could separate these, and I can write this as log base 3 of b plus log base 3 of y. Okay, we just have to recognize the operation in the input, and that allows us to expand it if we'd like. Okay, the next one, we have division. So we're going to subtract in this order. The numerator will be a positive value and the denominator will be a negative. So we have log base 4 of a minus log base 4 of t. Now, I could have also written this, okay? Just anything in the denominator will be subtracted. So I could say negative log base 4 of t plus log base 4 of a. Okay, so the denominator will be what's being subtracted, or that will be our negative value, and our numerator would be the positive value. All right, this is a combination of multiplication and subtraction here. Okay, and we also have a common log, so we don't have to write, since we're using the common log as well, we don't have to put a base 10 there, but you should know that it is an implied base 10. So this one we can write out as log of x. It's being multiplied times log y, so we're going to change it into addition, times log y. And the denominator would be subtracted, so minus log s. Okay, and again, since this is just, we have just these three terms, we could rearrange them. Okay, we could rearrange them and write it in any order. So if I wanted to, I could put log of x minus log s plus log y. Okay, and if I were putting those back into the consolidated form, into this form, I would know that the x and y would be multiplied on top because they're positive, and the s would be part of the denominator because it's negative. All right, log base 3 of 3 times x to the second power. Okay, so notice here, our x only is raised to the second power, and this is a product. So first I'm going to write log base 3 of 3, okay, plus log base 3 of x squared. Okay, now any input that has an exponent, we can also use, okay, this is called the power law. Okay, if our input has an exponent, we could bring it out front and it turns into multiplication. So this 2 is going to come out front, and it's 2 times log base 3 of x. And for log base 3 of 3, this turns into 1, okay? So this reduces to a 1. So our final answer would be this whole thing. Okay, so when we have log bases of numbers, like log base 3 of 3, there's no variable here, we should try to evaluate it if we can, if it easily evaluates. And since 3 is a power of 3, we know that just turns into a simple number 1. Okay, so now we're going to work backward. Okay, we see that these two logs have the same base, so we can actually consolidate them. If we see addition, that means that when we consolidate, it's going to go back to multiplication. So that would be the same as this. All right. For the next one, since there's subtraction, we're going to turn that into division. It's going to stay log base 4, but now we can consolidate the input as w divided by m. Subtraction will turn back into division. All right. Notice for the next, we have exponents. The multiplication out front, we're going to reverse those and put them back as an exponent. Okay, so that's what I'm going to do first if I see these coefficients out front. So first, I'm going to write it as log, and this is a common base, log of x squared, and I can put the exponent inside the parentheses or outside it. It doesn't really matter. The x is being squared either way in this case. And I'm going to write it still as a plus log y cubed. All right, so I just reversed those coefficients. I put them back as exponents because I'm reversing the process. And now since these logs are both common logs, they both have the same base, I can consolidate even further. And addition is going to become multiplication. So this is the same thing as x squared y cubed. Okay, log base 10, or common log of x squared y cubed. All right, and the last one. All right, notice all of these are log base 3s. There's no coefficients out front, so I don't have to worry about reversing any exponents. I just have multiplication because these are added, and then division. Okay, so since they're all log base 3, they can all be consolidated into one input. The t and b would be on the top, and the b is going to be on the bottom. And if I would have noticed this at first, we had opposites here, so they could have just canceled out from the beginning, And notice we can also cancel this out here. So this simply becomes log base 3 of t. Okay, so it's kind of interesting. You can see how the opposites will cancel out here. I didn't notice that, but they also cancel out here. So eventually they're going to cancel out to get log base 3 of t. Okay, if they did have a different base, we would not be able to do this. Okay, so I'm just going to add one more real quick. Let's say we have the same one we just did, but the last one had a base of 4. Okay, let me just put another example, and I'm going to change this base to a 4. All right, in this case, we could consolidate these. Okay, log base 3, and it would be bt or tb, right, as bt in alphabetical order. And we just have to leave it as minus log base 4 of b. We wouldn't be able to do anything if they have different bases, just FYI. All right, so we gave you these, you should have received a green little card stock of the log laws just to have out when you're working with these until you have them memorized. So it's there for your use, and that's what we just applied in the above slides. All right, there's a few more that involve the power law, actually all 3 laws, but notice the exponents are in different locations, and this matters, okay? So for the first one, this exponent of 2 only goes with the x. So I'm going to use the product law first and turn this product into an addition problem. I'm going to expand it. And since this 2 is an exponent, I'm going to throw it out front, and I'm going to rewrite it as just 2 log base 3 of x plus log base 3 of y. And I'm not very consistent, which I should be, about writing the input in parentheses or not. If it's just one item, you don't have to have parentheses. If it's more than one item, you should put parentheses around it. All right, in the next case, the y is the value that's squared. So this would be log base 3 of x plus log base 3 of y squared. And we're not going to leave the exponent there. We're going to throw it out front to put it in this form. So log base 3 of x plus 2 log base 3 of y. And after I move it, I probably should cross it off because they can't be both there at the same time. All right, this next one is different because the 2 applies to the whole thing. So what I'm going to do is take care of that exponent first. Okay. And if I do that, I need to remember that the 2, okay, goes with the whole thing. So I need these parentheses. Okay, the 2 is going to go with this whole log. So, and this is multiplication, so I'm just going to expand it now. So this is 2 log base 3 of x plus log base 3 of y. Okay, another way I could have attempted that from the beginning, I could have, since xy squared is the same thing as x squared y squared, I could have done this, and I could have did my log base 3 of x squared plus log base 3 of y squared, and then I could throw my exponents out front, multiply them. And basically this is the same thing, it's just the 2 is distributed. So hopefully you see that there's more than one way to tackle that problem. All right, same thing here, log base 3 of x divided by y squared. As long as you apply the exponent to both pieces, you can either put the 2 out front like I did here, or you can distribute the 2 to both pieces and do it like I did here. All right, so for this one, just because some students may forget to put the parentheses, I'm actually going to rewrite this first as log base 3 of x squared over y squared. Okay. And like I said, just because most students, or many, I shouldn't say most, will forget the parentheses, and if you don't have the parentheses, this would be incorrect. Okay, we have to have, the 2 has to apply to both logs. So maybe you want to distribute the exponent first, and since this is division, it's going to turn into subtraction. And then I do not leave those exponents up there. I bring them out front. So this becomes 2 log base 3 of x minus 2 log base 3 of y in expanded form. All right, so we're just practicing these log laws. Okay, so there's your little chart again that you guys should have, and we're going to go through the notes. So it says, which of the following is equal to log base 3 of 9x? Well, you may not notice, but 9x is really a product, okay? So we're going to use the product law, and we're going to turn this into an addition problem. And you can tell by the answers there's addition involved, so maybe that's a hint to you. So log base 3 of 9 plus log base 3 of x. And notice this answer is not one of the choices. So remember when I said when both of the base and the input are numeric, we should try to reduce. So 3 to the second power is 9. So this just turns into a 2, and we end up with 2 times log base 3 of x, which is choice 3. Okay, the next one. Okay, we have the division. So that's going to turn into subtraction. Again, you can look and see there's subtraction involved in all the answers, so that's kind of a clue. This is a common log, so the base is implied to be 10. And it's the log of the numerator minus that same log base of the denominator. Since we have an exponent, we want to move that out front. So this is going to become 2 log x. And if you notice, log base 10 of 1,000, this evaluates. Since 10 to the third power is 1,000, we just get this. So 2 log x minus 3 is our answer. All right. Exercise 3. Okay, they're giving us variables to substitute in for log 3 and log 2. And it wants us to evaluate log 12 in terms of a and b. All right, so in order to turn 12 into something that is equivalent using 2's and 3's, basically we're going to do that prime factorization of 12. Okay, we're going to break 12 up into its prime factors. And I really don't need to go to calculator soup or use my calculator for this. I can just break into any 2 factors, and then I'm going to continue until I have all primes. Okay, so log base 12, or I'm sorry, log of 12, log base 10 of 12, this is a common log. Common log of 12 is equal to 2 squared times 3. The log of 2 squared times 3. So now I'm going to use my laws, right? I have a product, so that's going to turn into addition. So log of 2 squared plus log of 3. And then my exponent of 2 is going to come out front. So I have 2 log of 2 plus log of 3. And now I'm going to use my substitution. So in place of log 2, they want me to substitute a b. So this is going to turn into a b. And in place of log 3, they want me to substitute an a. So this just turns into an a. So 2b plus a, or a plus 2b, it's the same thing. 2b plus a is the same thing as a plus 2b. All right, next one. All right, so when this is our first one where we're saying a radical, I highly suggest that you change the radical from the beginning into an exponent. So this is really x to the 1/2 power over y to the 5th. Okay. The next thing I notice is I have division. So I know division turns into, hopefully you said subtraction, in your head at least. You don't, maybe you didn't say it out loud. You're thinking it, I should say. All right, so this, hopefully you can see where this is coming from. And then I have these exponents. So the exponents become coefficients. And I have this 1/2 log base 2 of x minus 5 log base 2 of y, which is this guy. All right, exercise 5, same thing. We have a radical. Let's write it as a fractional exponent. So 5, the square root of 5 is the same as 5 to the 1/2. I have division, so I'm going to expand it into subtraction. I'm going to bring my exponents out front. And I'm going to evaluate this because I know 3 to the third power is 27. So right now I have 1/2 log base 3 of 5 minus 3. Oh, I don't see my answer here. Well, I know that this is not going to be equivalent because 1/2 log base 3 of 5 minus 3 is not equivalent to 2 times that. That's not it. Okay, I definitely don't want the plus 3. So if you were to think about it, if I were to divide, for number 1, if I were to divide both of these, since it's a binomial, this can be written as log base 3 of 5 divided by 2 minus 6 divided by 2. 6 divided by 2 is 3, and 1/2 times log base 3 of 5 is the same thing as log base 3 of 5 divided by 2. So number 1 is my answer. Okay, this one would not be equivalent. So sometimes the direct answer isn't there, but we can find an equivalent answer. Just be cautious about that. Okay, exercise 6, this is called the composition of functions, which we haven't learned this year. You won't have any on your homework, but it's not really that difficult, so I'm going to do it with you in the notes. Okay, so this is saying what's f of g of x. Okay, so g of x, normally when they give us a function notation, they just give us a simple number inside parentheses to input into our function, which f of x is log of x. So normally they just do this. They give us a number to input into parentheses that would replace this x. But instead of giving us a number, they're telling us g of x. Well, since g of x is equal to 100x cubed, that's what I'm going to substitute into my parentheses. Okay, so basically I have to evaluate this. All right, so I'll write that again. We have log of 100x squared, which is really 100 times x squared, remember. So that x1 of 2 is only going with the x. I'm going to expand it so my product becomes addition. And this is a common log. So log base 10 of 100, or the common log of 100, is simply 2 because 10 to the second power is 100. And for my x1 here, I'm going to bring it out front. 2 log x. Oh, I made a mistake. I transferred that wrong. So let's just fix that. And it shouldn't take too much time. I'm going to just change all those x1s to 3s. Okay, so that would change, the 2 would stay the same. I would just, my x1 here, right, that would be a 3. So therefore this would be a 3, and then this would be a 3. So that was a copy error, and then it just becomes this. Wasn't too bad to fix that. All right, exercise 7. If you want to try this one on your own, you can. This one's a little bit different, though. So log base 2, in this case, the whole 32 x to the 7th is to the 1/2 power. Okay, so since, oops, I'm going to pause it for the pledge if I can. To the flag. All right, guys, sorry about that. Okay, so back to exercise 7. So notice the 1/2 power goes with the whole thing. So what I'm going to do first is I'm going to take that 1/2 and I'm going to put it out front, and I'm going to take care of it right now. Okay, so remember when we do this, we have to be sure to put this in parentheses because the 1/2 applies to this whole thing. All right, so now I have the log base 2 of this product, so log base 2 of 32 plus log base 2 of x to the 7th. This 7 only went with the x in the original problem, so I'm going to throw that in front of just this log, and I'm getting there. I'm going to need to simplify my answer. Okay, again, log base 2 of 32 I can evaluate. Since 32 is a power of 2, it's the 5th power, so this just turns into 5 plus 7 log base 2 of x. And everything is to the 1/2 power, which is the same as just, I'm sorry, everything is times 1/2, which is the same thing as dividing by 2. And I see my answer right here, number 2. All right, exercise 8. This is very similar to the one where we broke down 12. It wants us to basically split log of 4,900 into primes, okay? Or you really don't have to go as far as primes. Hopefully you recognize this as 49 times 100. And 49, since they want us to break it into some form of 7, we have 7 squared times 100. Okay, and since this is a common log, eventually the log of 100 is going to turn into a whole number. So I can just write this as log of 7 squared plus log of 100. All right, so like I said earlier, the common log of 100 is simply 2. This exponent I'm going to put out front. So it's just 2 times log 7 plus 2. Log 7 is going to turn into k. So this is the same thing as 2k plus 2. And again, my answer is not there directly, but if I distribute the 2 on number 1, I do get 2k plus 2. So the equivalent answer is there. So don't stress out if you don't see your answer directly. Just think about it. Look for an equivalent answer. All right, so your homework, okay, your homework for this is you are going to do numbers 16 through 33. Okay, 16 through 33. And just so you know, I think we might have skipped over a page for you. Oh yeah, so your homework starts on page, you're going to find it on page 17 and then continues on to 18. And for questions 22 through 33, ignore these directions. Okay, don't worry about that whole A and B thing. Just expand your logs like we practiced in the lab. All right, so everything looks pretty straightforward. Expand those logs. Expand these logs. I'm going to do number 32 with you. So log base 2 of x times the square root of x. Remember I said you could rewrite any radical as the 1/2 to the 1/2 power. All right, so we can actually simplify this before we don't have to expand it separately. Since this is x to the first, and we're multiplying, we can add these exponents. So this is going to turn into log base 2 x to the 3/2 power. And then since we have an exponent, we're just going to throw it out front. So that's going to be 3/2 log base 2 of x. Okay. All right, so finish 16 through 33. That's your homework, and hopefully you enjoy these. I think they're kind of fun. All right, have a nice day, guys.